Gwelson, can you see the PowerPoint slides?
I can see them very clearly. Thanks, Lynn.
Thank you, Doug. All right, yes, so sorry, you're going to be hearing from me again, and I'm going to go quite quickly through this presentation because I have 3 species to cover, so apologies for that, but I want to do my best to stay on time. So I'll begin by talking about yellowfin tuna. So we had tagging data from AOTTP's database, and once we filtered it, that became 4,009 data points from ICCAT, which was 113 after filtering, and then length age pairs from the AOTTP collection, from Shuford's dissertation, which included data from Shuford, Lang, and Gasquel. There was also a paper in 2020 by Andrews and Pasico and others that used bomb dating of otoliths, along with some spine data from Gwelson da Silva. And soon we'll be adding more data to this from the AOTTP reference collection for otoliths. This is what the AOTTP tagging data looks like. We determined that 60 days would be our cutoff for all data sets for tagging data for the time at liberty to avoid biases in the growth immediately after tagging. And then this panel over here shows the recovery lengths and the release lengths of the fish, and they range from 25 to 169 centimeters. For the ICCAT tagging data, again, we use 60 days as the cutoff. There was 113 pairs, and the recoveries and releases range from 25 to 169 centimeters. In particular, we wanted to look at 2-stage growth for yellowfin tuna, and we investigated this with spines, which relies on the Bryan model that we just presented and found no evidence. We also investigated this with a set of otoliths where the size of each ring was measured, and I'll show that to you next, but this is also a plea. If you have an otolith data set where you've measured the width of every ring, we would very much be interested in that data and collaborating with you, so please let us know. We are working on a separate theory paper on causes of 2-stage growth. So for the purposes of our model, we treated it as 1-stage growth, but these are those results from the otoliths where the measurement of each ring were made. We had a total of 10, and this is a plot of just 5 of them. Of those 10, 2 of them showed evidence of 2-stage growth. And you can see one of those fish here where it happens at age 6, there's a slight slowing down in the growth of the otoliths and the ring widths. For the other fish that exhibited this slowdown, the slowdown occurred at age 3. So right now we're not saying that this is conclusive that there's 2-stage or inconclusive at 2-stage, but saying rather we need more evidence to determine it. But it's looking unlikely at the individual level at this moment. And then here are the results from the integrated model where we used tagging data from AOTTP and ICCAT along with hard part data from Shuford, AOTTP, the spine fit with Bryan, and the Andrews et al. And these are the von Bertalanffy parameters. The Bryan points are these gray points which are lower than everything else. And it's also worth pointing out, based on previous discussions, that the Shuford et al. Data set does include daily age ratings beyond that 1-year point. So that's something we're going to revisit and address and see how the model alters when we only use daily for less than 1 based on advice we've now received. So now I'll be switching to Bigeye. For that, we have 3 sources of tagging data: AOTTP, ICCAT, and Hollier. And then we have length age pairs from the AOTTP collection, as well as from Hollier's data set. And soon we'll be adding the Andrews Pasico paper, bomb dating, otoliths, and then also the AOTTP reference collection. For the AOTTP tagging data, we determined that 98 days would be used as the cutoff for time at liberty. So we only retained fish that were at liberty for longer than that. This left us with 1,572 pairs, where the fork lengths from recovery and releases ranged from 28 to 150 centimeters. From the ICCAT tagging database, again, we used that same cutoff of 98 days. We only had a sample size of 19 fish now, with fork lengths ranging from 13 to 203 centimeters, with recoveries and releases shown here. For the Hollier tagging data, we processed it the same way as the other two data sets. So rather than the time at liberty cutoff they originally used in their paper, we still applied that 98 days to be consistent across all data sets. And so that left us with a sample size of 146 with fork lengths ranging from 39 to 114 centimeters. Recoveries shown on the top panel and releases shown on the bottom panel. And these are results from the integrated model. So this is using tagging data from AOTTP and ICCAT, and then hard part data, and also Hollier's tagging data, and then hard part data from AOTTP and Hollier, although following the advice of not using daily readings for greater than 1 year. For the Hollier data, we have truncated it to only include those otoliths that had daily age readings that were 1 year or less. So those are what are shown in gray, and that's why they're only for very small fish. And then the AOTTP collection extends over a wider variety of ages. And these are the von Bertalanffy parameters shown here from this first integrated model run. And again, I'm showing von Bertalanffy curves here today just because of the time constraints, but we have run other models and other iterations, but there's only time for me to show you just one example for each species. And since we're still receiving more data, we haven't determined the final best model for each species. And we're also hoping, in case anyone else has data that might be useful for us, to make one last plea to please contribute to the project. So the final species is Skipjack tuna. And for that, the data was a little bit more limited. We have tagging data from AOTTP along with ICCAT, and then length age pairs from AOTTP daily otoliths, which is a sample size of 5. And then we have spines provided by Guilson da Silva, which is 298. For the time at liberty cutoff for Skipjack tuna, we used 84 days, which for the AOTTP data left us with 769 pairs with fork lengths ranging from 13 to 104 centimeters. For the ICCAT tagging data, the 84-day cutoff left us with 2,758 pairs with fork lengths ranging from 25 to 169 centimeters. Now, when we went to combine these two tagging databases, we noticed that the growth rates are different. So here is a histogram showing the weekly growth rate between AOTTP and ICCAT, where AOTTP are these green, which are, it's less data, so they're shorter, and the purple is the ICCAT. And the mean and median from the ICCAT tagging data for weekly growth was higher than AOTTP. If we look at this data another way, now the x-axis is time at liberty in weeks, and the weekly growth rate is on the y-axis. The blue or teal dots are ICCAT data, and the orange or pink dots are AOTTP data. Once again, you can see that that mean weekly growth rate from the AOTTP data is lower compared to the ICCAT data. And they cover relatively the same time frame of time at liberty. Now, if we plot the ICCAT versus AOTTP data in terms of fork length and weekly growth to see if it's effective size, and their dashed lines here are from the median for each data set, again, with the median of ICCAT being higher than the median of AOTTP. The ICCAT database did have fish of a release length. These are both release lengths here for the fork lengths. The release lengths were higher for ICCAT. So again, I think that this difference is real. We haven't been able to tease apart what could it be caused from yet. So as a result, we have not combined these data sets. For the otoliths too, we also have the unresolved issue of being able to possibly use any of the otoliths greater than 1 year. I'm hoping to hear more about that today. And then the spine data set, it looked like the fishery had some strong selectivity, and that the sampling of young fish was biased. We're also catching the largest small fish perhaps, and there might be a possible lack of older fish in this spine data set. So when we apply just the Fabens model to just the AOTTP tagging data, using the Fabens 2 method and FSA package in R, or Wang, these are the von Bertalanffy parameters that we get. Fitting the ICCAT data, only the Fabens model converged, but it looked horrible. These are the residuals. So as you can see, these are horrible residuals. So I'm not going to present the growth parameters from that. And this was the Bryan model fit to spine data, where the x-axis is the estimated ages from the Bryan model. The y-axis is the small spine width. Red is the naive model, so you can see it again shooting off to a very high D infinity because it doesn't catch the curvature. And the Bryan model is very low, and again, that's because all of your data is here in these younger fish, and we have concerns that also for these younger fish that we're getting the biggest of the young fish. So we're not very confident in using this data. When I combine the AOTTP tagging data with the Bryan ages from the spine data provided by Guelson da Silva, this is the curve we get. These are the Bryan spine ages. They're below the curve, and these are the parameter estimates. Again, we're not happy with this one yet. We're still working on it in terms of being able to provide an integrated model and combining data sources. We were unable to run the integrated model just using AOTTP tag data along with the 5 AOTTP otoliths because the data set for the otoliths was just too small, so the model would not run. So we still have some work to do for all 3 species, but for the sake of time, I'm going to move through this slide quickly. But I just want to acknowledge the funders for the project being AOTTP and all of the people who have provided data, and also thank the organizers of this conference. It's been a wonderful morning so far.